Hello again. Today we're going to build the ESR meter, the Bob Parker Blue ESR meter. I already opened it up because I needed to use these little clips. Now, if you've ever watched any videos on YouTube where someone has been repairing a device, chances are you've seen the Bob Parker ESR meter. The one I always usually see it's the older black model that's in a black case with just banana plugs, banana jacks on the front, and a little chart that says, good, bad, like the maximum ohms based on how many microfarads and volts. Unfortunately, they don't make that one anymore. The one that they make now is the blue model, which, I mean, it'll work. It'll work. The thing I don't like is it doesn't have you hard solder the leads directly to the board, which I don't like that, but whatever. I figure at some point down the road maybe I'll look into maybe modding on some banana plugs on the top. That way I can change it around if I want to, or if I need to change the leads. So in the package you get the case, a couple stickers for the case once you're done, the lead wire, the circuit board, single-sided. On it, which you can see on the actual board, you'll have all the parts numbers, the resistor values, the capacitor values, everything is on here. So you could pretty much just use this to build it and not look at any instructions. Which you actually don't get instructions with this. You get at least from the place I bought it off of a seller on eBay, but he just had this basically saying Blue ESR meter. There's forum, assembly, and user manual is at this web address. It does not give you physical copy of the instructions. This is just my eBay receipt. So you can see there, nothing. And they individually package the resistors, and, well, all the parts. You have the, what is that, 8 segment, or is it 8 if it has the dot? I'm not sure. But the chips and the displays, semiconductors, miscellaneous parts, alignment and tests, which are just two resistors, some capacitors. Then they give you 5% resistors and 1% resistors. They don't actually mark the values or anything like that, but that's not a problem. And these little clips, they came out of the miscellaneous parts bag. So I could just wing it and start assembling the board, but I think I'm going to actually look at the instructions. Okay, I have the instructions loaded up. They actually give you a list of all the resistors and their color codes. That would make it easier. The recommended installation sequence is 1% resistors, 5% resistors, the semiconductors, But it does say do not install the LEDs until you install the 7-segment displays. For some reason. I'm sure they have a reason. Then the capacitors, and then the miscellaneous parts. So, let's move these bags over here so I don't screw anything up. Or at least lessen the chance that I screw something up. And there are only 4 1% resistors, so this should be fairly easy to do. The regulator. On the board, it's marked LP2950, but the regulator itself is actually marked, and in the instructions it does mention this, that it might be marked differently. This one is actually marked KY5050. Polarity matters with the diodes. And on the boards here you can clearly see one side is marked with a line through it, and that will coincide with the little mark on the diode. Either the gray mark on the 07s and the black mark on the 48s. The instructions suggest that you hold the circuit board up against a bright light and inspect the traces for any hairline fractures. I did not do that prior, but really I see no problem with this board at all. And actually, if I would have actually followed the instructions 100%, they do give you an assembly order that includes the individual parts. So really I should have put these little tiny little diodes on first, but I didn't. So now they're kind of hard, you know, you got to make sure I hold them up against the board since I have these transistors raising the board up against my, up off of my work surface. But the instructions do instruct you to put the smallest parts on first. I just didn't do that. I really wish they just would have went with the banana jacks on these, but I'm guessing this was just cheaper. But it shouldn't be that hard, I doubt, to mod this later on. Okay, now we have these little rubber, basically standoffs. These go underneath the 7-segment displays. They give you the option, you can either mount sockets or just mount the chips directly to the board. I might as well use the sockets, I think. Now it's interesting because they have you put these rubber feet underneath the 7-segment displays. They actually sit almost completely up off the board. You probably needed it that height for the displays to sit right up against the case so you can see the numbers easily. You need to have the top of the LED be flush with the top of the 7-segment display. I think I'm being much too persnickety about this. I think it just can't be over the 7-segment display, and it can't be too far beneath it. Alright, I have the battery connected. Everything's ready to test out. I went ahead and put the clips on the end of the test leads. Now it says the initial check, everything's connected. Push the button, but it says you should just get this little dash. Then Push the button again, turn off. Then turn it on and short the leads, and you'll get a reading. This is the resistance of the leads itself. And then you hit the button again, zeroes it out, and the left decimal is lit. Everything looks to be good. Now for the calibration, you use these two supplied resistors. We turn it on. It's so hard to read on the screen, to me anyways. Then we short the leads to zero out. Zero it out. You take the 82 ohm resistor, and you connect, and then you adjust, which one? VR2. Which one's VR2? The board, the one thing I really dislike about the way the instructions are set up in regards to the board is the instructions will mention like R5 and VR2 and VR1, but the board is not marked in that manner. The board is only marked 10K variable resistor, and what was the other one? 200 variable resistor. So the board isn't marked in how they're referencing the components, and I don't like that. It's kind of irritating to me. But so then you have to go back through and see that VR1 is the 10K and VR2 is the 200 ohm. I mean, it's on the schematic, not the schematic, the board layout diagram that they supply within the instructions. It is labeled VR1, VR2. You know, all the parts are labeled in that manner, but it's not labeled that way on the board, which it's just frustrating when they don't give you a physical copy of the manual, so you can't have the board diagram in one hand and in the other hand have the instructions telling you to adjust VR1. But whatever. VR1 is for the battery warning. VR2 is to adjust the calibration. Okay. So what is this? It's an 82 ohm and the battery timeout. Yay. So now I have to re-zero everything. Short. And just VR2, which is the 200 ohm, till it reads, till you can't see with my hand in the way. Adjust that down slightly till it reads 82. Then it says to take the 5.6 ohm resistor and measure that and see, should be somewhere between 5.4 and 5.8, which is 5.5, and the center decimal point is lit up, so it's looking good so far. Okay, now it's telling me to set up the battery warning. Now it says it's easiest to do it with a DC power supply. Alright, ESR meter off and nothing attached to the test leads. Turn the 10k ohm resistor fully clockwise. Alright, what do I do with my screwdriver? So fully clockwise. Okay. Adjust the supply voltage to 5.5 volts. And you probably aren't going to be able to see my power supply over here, but that's fine. Switch the meter on. Slowly turn VR1 counterclockwise until B indicator begins flashing on the right hand display. So I'm assuming the right hand 7-segment display will begin flashing B. Alright, it's flashing a B. Turn the meter off. Wind the power supply up to 9 volts. Alright. Up to 9 volts. Turn it on. And then slowly drop the voltage on the power supply and check. I'm at 7.4 now. 6.0 should start flashing once I get to 5.5. And there we go, 5.5, and it's flashing. So that looks good. Alright, there it is all together. And go ahead and hook the battery back up. Put the battery door on. Test it out. I happen to have a couple capacitors here. They are bad. The caps are bulged out on them. But we're going to go ahead and see test this thing out. Turn it on at 0 it out. And there we go. 1.5 ohms. This is a where is it? 16 volt, 1000 microfarad. And we have this chart here. And we have 16 volts, the second column here, and it's 1000 microfarad, so it's greater than 500, so it should be between well less than 1 ohm. The range on the left here goes from 0.1 ohm all the way up to 100 ohm. So it should be, based on this, say 0.4 ohms, and it's coming up 1.5. I mean, obviously it's bad because of the bulging on the top. This other one over here, same 16 volt, 1000 microfarad. Pop this on. 1.6, again, bad. But we knew that. So looks good. Everything seems to be working out great. If something is wrong with the meter, it can do some self-tests, and it will tell you what the problem is and what to check to see if something is messed up in it. Which that is very nice, very good. So I hope you enjoyed the video. Thanks for watching.